Hello, this is Garrett Keane. In this video, I'm going to run through the procedure to calculate the x and y coordinate for the centroid of a plane area. In this case, the function is y is equal to x squared plus 2x plus 1. So we're looking for the centroid of the yellow area defined under this curve between the upper limit x is equal to 1 and the lower limit x is equal to 0. So we're looking to locate the x and y coordinate of this centroid. In this slide, the equations to determine the centroid of a plane area will be presented without proof. The centroid, if you look at this here, you have your function f at x, you have the vertical ordinate x equal to small a, x equal to small b, and the x-axis. These four lines define the area which you see under the curve in here. This is a plane area, and the centroid of this plane area is denoted as here with the letter C. And the centroid is another word for the center of gravity. If you were to cut a cardboard page out in this shape and then balance it on a pen and position the pen at this point, theoretically, the piece of paper should balance on that point. That is what the center of gravity is. The location of the center of gravity, it has an x coordinate, which is denoted x bar, and a y coordinate, denoted y bar. To work out those values, the first parameter we need to work out is I2. And I2 is the area underneath the curve. The area underneath this curve between the upper and lower limit, between small b and small a. This parameter I2, or the area, will be used in the calculation of both x bar and y bar. To calculate x bar, we need to work out the parameter here, which is I1. And basically, in I1, every term in the equation for y, whatever that might be, is multiplied by x, and then the result is integrated between the upper and lower limit, b to a. When you work out I1, you could then work out x bar, where x bar is equal to I1 divided by I2, and that will give you the location of the x coordinate of the centroid. To work out y bar, we have to work out this parameter called I3, and I3 is equal to half times the integral of y squared integrated between the upper and lower limits b to a. When you've worked out I3, y bar is equal to I3 divided by I2. So basically, to work out x bar and y bar, you have 5 calculations which you must carry out. As stated in the last slide, our first step is to work out I2, which is the area under the curve. Our function in this case is y is equal to x squared plus 2x plus 1, so we have this quadratic. It's a direct integration, so I2, which is the area, is the integral from 1 to 0 of this function. The integral of x squared is x cubed over 3. The integral of 2x is the integral of x is x squared over 2, and the integral of 1 is x. So showing this answer here, we have x cubed over 3 plus x squared plus x. And our upper limit in this example is 1, the lower limit is 0. So if we plug those values in here, you can see in red I have the upper limit, which is the 1, and in blue I have the lower limit, which is in blue. If you evaluate these, all these go to 0. And here we're left with 1/3 plus 1 plus 1, which is equal to 2, and 1/3, which is 7 over 3. The formula for I1 is the integral from 1 to 0 of x times y times dx. We take our expression for y and we substitute it in here. So we have the quadratic x squared plus 2x plus 1. We multiply every term in that quadratic by x. So we're looking to integrate x cubed plus 2x squared plus x. If we go ahead and do that integration, x cubed becomes x to the power of 4 divided by 4. 2x squared becomes 2 times x cubed over 3. And x becomes x squared over 2. The limits of the integration are plus 1. The upper limit is plus 1. The lower limit is 0. We substitute those values in. The upper limit is shown in red as 1, and the lower limit is shown in blue as 0. When this is evaluated, all the terms on the right-hand side will go to 0, and on the left-hand side, we have a quarter plus 2/3 plus a half. To add these up, the lowest common multiple of 4 and 3 and 2 is 12. So we express a quarter as over 12. It's 3 over 12. Because 4 goes into 12 3 times, and you multiply that by the 1. Here we have 2/3, which is equivalent to 8/12, and a half is equivalent to 6 over 12. We add the 3 values up, the 3, the 8, and the 6, and that will give us 17 over 12. From our formula, I3, which we need to work out y bar, is equal to a half times the integral from b to a of y squared dx. So we take our expression for y, in this case it's quadratic equation x squared plus 2x plus 1, and we need to square it out. To do this, we can use a table. We arrange each term across the top, x squared, 2x plus, and the 1. Likewise, we arrange it down here, x squared, 2x1. We multiply the first row by x squared. So x squared by x squared is x to the power of 4, shown here in red. 2x by x squared is 2x cubed, shown in green. And 1 times x squared is x squared, shown in blue. Then, for the second row, we multiply each term in the quadratic by the second term, 2x. Here we get 2x times x squared is 2x cubed. The x cubes are shown in green. 2x times 2x is 4x squared, shown in blue. And 1 times 2x is 2x. The last one is multiplying this row here by 1. So I just copy it down. So every term with x squared is shown in blue. You see those on this diagonal. X cubed is shown in green on this diagonal. X to the 4 is on its own out here. And 2x and 2x are here, and the constant 1 is out at the end. I take those values and put them in here. And now our formula is in a format in which we can now integrate it. The integral of x to the 4 is x to the 5 over 5. The integral of 4x cubed is x to the 4 over 4, but it's multiplied by 4, so the 4's cancel. 6 times x squared, the integral of x squared is x cubed over 3. 6 divided by 3 gives 2, so we end up with 2 times x cubed. 4 times x, the integral of x is x squared over 2. 4 divided by 2 gives me 2, so we have 2x squared. The integral of 1 times 1 is x. This is from the upper limit of 1 to the lower limit of 0. So I plug the upper limit in here, shown in red, along here for each term, substitute in 1 for x, and here I substitute in 0 for x. Every term on the right-hand side will evaluate to 0. And then if we work out the terms on the left-hand side, I have 1/5 plus 1 plus 2 times 1 cubed plus 2 times 1 squared, giving me 2 plus 1. So if I add these up, I have 1 plus 2 plus 2 plus 1 is 6. I have 1 over 5 here. So 6 expressed as a factor over 5. 6 times 5 is 30, so it's 30 over 5. Plus the 1 here gives me 31 over 5. I'm multiplying that by the half, so I3 evaluates to 31 over 10. Having calculated I1, I2, and I3, on this slide we'll finish off by calculating X bar and Y bar. We must first recall the value of I2, which is 7 over 3, and that will be used in the calculation of both X bar and Y bar. For X bar, recall the value of I1, which is 17 over 12, and then X bar is equal to I1 divided by I2. So it's 17 over 12 divided by 7 over 3. We bring the 3 up on top. So it's 17 times 3 multiplied by 7 times 12. And the 3 will go into the 12 4 times. So that gives us 4 times 7 is 28. So it's 17 over 28. For Y bar, we must recall the value of I3. So I3 will be worked out to be 31 over 10. Y bar is equal to I3 divided by I2, which is 31 over 10 divided by 7 over 3. We bring the 3 to the top. 31 over multiplied by 3 over 7 times 10. There's nothing there to be cancelled, so we end up at 93 over 7. So in summary, X bar, Y bar is 17 over 28, 93 over 70, and if we work those values out, it's 0.607 and 1.33, which if you look at the function is a reasonable value for the location of C. Okay, that's it. Thank you for listening.